Welcome to this VMware Cloud Foundation Networking Deep Dive. My name is Andrew Firth and I'm a Senior Architect in the Cloud Foundation team. Networking is a core component of Cloud Foundation's software-defined capabilities. And today I'm going to take you through how to set up and deploy networking in a Cloud Foundation environment. Understanding Cloud Foundation networking is key to planning and scaling a deployment. When VCF is first deployed from bringup, each host is configured initially with 4 VLANs. 3 of these VLANs are deployed as VM kernel ports, which traverse the virtual distributed switch using familiar vSphere networking. The VDS is configured with load-based teaming to optimize network traffic flow. These 3 networks comprise of VLANs for management, vMotion and vSAN, and are configured following VMware best practice. The ESXi host management IP addresses are configured at the time of imaging each host. The ESXi host management IP addresses and the core management components of the platform, which include vCenter Server and SDDC Manager, are deployed to the management network. ESXi is deployed as part of Cloud Foundation to enable software-defined networking and security. ESXi Manager is also configured on the management network and is deployed as a fault-tolerant 3-node cluster. The 4th VLAN is used by NSX to configure a host overlay network. This host overlay forms the basis of software-defined networking. Let's take a closer look at the host overlay network and how it's used in a Cloud Foundation deployment. Each host within the VCF workload domain is connected to one another using NSXT host tunnel endpoints, known as taps, to form a full mesh between them. The taps on each host are configured with IP addresses on their own unique VLAN and serve as the on and off ramp to the mesh. This special host tap network is also known as the NSXT overlay network. The host overlay network is used to carry Geneve encapsulated traffic between hosts. Customers can start leveraging SDN immediately once Cloud Foundation is deployed. NSXT Manager can be used to deploy logical networks dynamically when they are needed. These logical segments tunnel through the NSXT host overlay over the top of the physical network. Being software defined, these logical segments can be quickly deployed and just as easily pulled down. Virtual machines and container services can be connected to one another on these logical segments. Logical segments within the overlay can be switched and routed to one another using software controls within NSXT Manager. This allows for administrators to make networking changes dynamically, which are completely independent of the physical network. This is the basis of software-defined networking. Tap network traffic is segmented from other network traffic by the assignment of a user-defined VLAN ID. Host tap IP addresses are assigned by Cloud Foundation in one of 2 ways. They are assigned, rather than manually configured, to allow SDDC Manager to scale the SDN mesh as hosts are added to the platform. The method chosen for the deployment of the management domain is configured within the deployment parameters worksheet at the time of initial deployment. Host tap IP addresses can be assigned from an external DHCP service provided by the customer, or host tap IP addresses can be assigned from an IP pool, which dynamically allocates IP addresses when they are needed. Leveraging IP pools for the assignment of the host tap interfaces provides several benefits. There's reduced complexity. Using an IP pool eliminates the need for external DHCP service integration. It also eases management. As it's part of NSX Manager, an IP pool can easily be managed by the SDDC administrator. And for lifecycle management, customers no longer need to maintain an external DHCP service as the NSX managers are updated and patched through the SDDC Manager. Regardless of which method is used for host tap IP address assignment, care needs to be taken to ensure that the IP scope is large enough to satisfy the needs of all the hosts within the cluster, as well as allowing for future scale. VMware recommends the use of IP pools where possible. IP pools are simple to configure and typically easier to manage when compared to an externally managed DHCP server. NSXT host tap IP address assignment is also configurable post-deployment. It can be configured from within SDDC Manager or by using the API. When creating a new workload domain or when adding a cluster through SDDC Manager, the user is prompted to select an option for how IP addresses are allocated to the NSXT host taps. This example shown here shows a relationship between the host taps and a customer-managed DHCP server. This second example shows the difference when IP pools are configured. If an IP pool is chosen, the user is given a further option of creating a new IP pool or reusing an existing IP pool. An existing IP pool can be one that has been created by VCF previously, or it could have been created manually by the user from within NSX Manager. A new IP pool will always be required when configuring the first VI workload domain. And this is because the first VI workload domain configures a separate NSXT fabric to that of the management domain. This diagram here may help to make things a little bit clearer. Cloud Foundation uses IP pools or DHCP to automate the assignment of IP addresses to the NSXT host taps when configured using overlay networks. This allows clusters within the platform to scale quickly without having to make complex manual changes. Cloud Foundation also uses automated IP address assignment to configure vMotion and IP storage. Where new hosts are commissioned into the Cloud Foundation inventory to scale the platform, SDDC Manager uses network pools to configure vMotion and IP storage addresses. IP pools and network pools are not to be confused with one another. They refer to two very different processes for automating IP address assignment within Cloud Foundation. They can both be used for IP address assignment at bring-up, and they can also both be used by SDDC Manager during scaling operations post-deployment. Let's take a few moments to take a closer look at network pools. As part of the initial deployment of Cloud Foundation, a network pool is created which contains IP address ranges for vMotion and vSAN traffic to use. These IP ranges are entered into the deployment parameter workbook or the JSON file used for bring-up. A network pool name and a range of IP addresses is configured for each network. Network pools are also used by Cloud Foundation during automated post-deployment scaling operations. When administrators create a new workload domain or add a host to an existing workload domain, SDDC Manager will assign IP addresses for these pools. And this saves the user a lot of manual IP address configuration of each new host. Network pools can be created for a number of use cases, such as when commissioning hosts that require network isolation of vMotion or IP storage networks, as well as when enabling the use of additional principal storage types, such as NFS or vVol support when creating a new workload domain. It is important to plan for scale when defining subnets in any network pool. Additional IP ranges can be added at any time, but the original subnet cannot be changed. Additional network types can't be added to a network pool after they've been created, so consider adding additional network types that may be needed in the future. When planning your Cloud Foundation deployment, it's also important to consider the number of vSphere distributed switches that are needed and the number of physical network interfaces on your ESXi hosts. A host deployed at bring-up is configured typically with 2 pNICs as the default. 2 gig minimum, 25 gig or greater is recommended. Cloud Foundation has support for creating up to 3 virtual distributed switches, utilizing up to 6 pNICs in the management domain. Customers can also add additional pNICs to the existing VDS to take advantage of greater bandwidth. Or they can create an additional VDS for use cases where isolating traffic is important. Some customers may want services being delivered from a different pair of top of rack switches. This is also supported. In the large majority of cases, the default configuration of 2 pNICs provides more than enough bandwidth. The Cloud Foundation Deployment Parameters Worksheet allows customers to define VDS profiles and deploy multiple VDSs during the initial deployment. The bring-up process facilitates deploying hosts with 2 or 4 pNICs using the deployment parameters worksheet. Customers looking to deploy 2, 4, or 6 pNICs can also use the API. To configure 6 pNICs, the API must be used. Within the deployment parameters sheet, there are 2 profile types to choose from, which provide different levels of traffic separation. The first profile allows more pNICs to be added to the default VDS, and the second profile separates vSAN traffic in a second VDS. So in wrapping up, let's bring all these concepts that we've discussed together. This might help give you a clearer view of VCF networking concepts. Cloud Foundation requires a minimum of 4 ESXi hosts, each with a minimum of 2 pNICs. 10 gig minimum, 25 gig or greater is recommended. As part of Cloud Foundation Bring Up, a virtual distributed switch is deployed with load-based teaming to optimize network traffic flow. The architecture and best practice configurations are fully documented in the VMware Validated Solutions collateral. Here we can see the core vSphere networks, management, vMotion and vSAN configured as VDS port groups. An IP address assignment for vMotion and IP storage is automated using network pools. Here we can see the ESXi host overlay network, also known as the host tap network. The host overlay network can be configured with an IP pool or with DHCP and is used to carry encapsulated traffic between the hosts. Management components such as the Management vCenter server, the NSX management cluster, and SDDC manager are configured to the management network during deployment. SDDC manager contains several inbuilt automated workflows which can be run post-deployment to help simplify the configuration and consumption of software-defined networking. And that concludes our short deep dive on Cloud Foundation Networking. Please join me in our next video where we'll build on our knowledge of Cloud Foundation Networking and further explore more advanced software-defined networking and security concepts. My name is Andrew Firth from the VMware Cloud Foundation Technical Marketing Team. Thanks for tuning in.